In the previous video, I discussed how to perform assumption tests for OLS regression model for a time series dataset. The video explained what assumption tests are and how to perform assumption tests using STATA. Find the URL to the previous video in the description. Now, moving forward with the analysis, the next step is to create an OLS regression model. The first thing to understand is that, even after satisfactorily fulfilling all the assumptions like stationarity, normality, multicollinearity, heteroscedasticity, and autocorrelation, the OLS regression model can be still inefficient. Inefficient means that the p-value of the regression model is more than 0.05. When the p-value of multiple variables in a regression model is more than 0.05, the null hypothesis gets accepted, indicating that there is no relationship between the variables. This is undesirable. A high p-value renders the study inconclusive. This can be done in 3 ways. The first method is to eliminate the variables with a very high p-value. For example, assume we have 4 variables: FDI, exports, imports, and exchange rate, and I want to check how they affect India's GDP. The p-value of each variable's regression is coming out to be more than 0.10, with imports showing the highest value of 0.15. In this case, we can remove imports as a variable from the dataset, and hope that this brings the p-value to our desired limit of less than 0.05. Another method to bring the p-value below 0.05 is by changing the model. For example, we can experiment with GLM model instead of OLS regression when the dataset is nonlinear. The third method is to change the data. I will be continuing with the example dataset from the previous video. If you haven't yet seen it, then find the URL to the previous video in the description. Out of the 5 assumption tests that we had conducted in the last video, we created a model to remove heteroscedasticity from the dataset. The results of the model show that the R-square and F values are acceptable, but the p-value of every variable is more than 0.05. Therefore, we must modify this regression model. For this, we will first exclude the most insignificant variables from the model. These are DTO, DIN, and DIE. As the values are more than 0.6 for each of them, we will try to use the GLM regression model. The command for creating a GLM model is Another way of building a model is using the inbuilt functions. Click on Statistics, then Generalized Linear Models. A dialog box will appear showing the family and the variables selection bar. Here, by default, Gaussian will be selected. Now, from the drop-down menu for the dependent variable, select the DCA variable. In the drop-down menu for the independent variables, select dGDP, DPI, DG, DTO, DTB, DED, DFD, DFDI, DDBM, DI, DIN, and DIE. Now click on OK. The results show all the variables still has a p-value of more than 0.05. Retry the variable elimination method. The highest insignificance level for DGE, DTO, and DFE is 0.880, 0.809, and 0.792. Enter the same command in the command box and remove these variables. The results of the model show that now the p-value of 2 variables, DTB and DDBM, is less than 0.05. For variables DPI, DED, and DFD, the p-value is less than 0.10. Therefore, the significance is derived at a 10% level of significance. Hence, we can conclude that with a 1% rise in the trade balance, external debt, and broad money supply, the current account balance rises by 0.01%, 1.17%, and 0.26% respectively. While a 1% rise in private investment in fiscal deficit decreases current account balance by 175.28% and 0.19% respectively. Therefore, private investment, trade balance, external debt, fiscal deficit, and broad money supply are important components that define the current account balance of the Indian economy.